So this all seems fairly straightforward if I got numbers like 10 or 100 or 1,000, which are easy to write as powers of 10. But what if I've got an equation like this one, 10 to the 2x equals 50, and 50 now is not as easy to just look at and write as a power of 10. Except I remember that I have this special button on my calculator called the log button, which lets me essentially write any number as a power of 10. So if I just take this side of my equation here, which is 50, and if I write, or rather if I calculate the log of 50, and I punch it into my calculator, let's see, log of 50, I see the log of 50 is 1.699 approximately. So log of 50 is 1.699, which means I can write 50 as 10 to the power of 1.699. That's what the log of 50 means. So I can write my equation then as 10 to the 2x equals 10 to the power of 1.699. And now I can use the same rule I've been using. I've got a to a power equals a to another power, the same base raised to a power, which means that I can set my powers equal to each other, just like I was doing before. And 2x equals 1.699. And now I just need to do a little bit of algebra. Divide both sides by 2. And I get x equals 1.699 divided by 2, which is 0.8495. And there's the solution to that equation. Let's try problem G. Again, I've got 10 raised to a power equals a number that's not easy to see what that number is as a power of 10. But again, I know how to calculate, or rather I know how to write this number as a power of 10. I do that using the log button on my calculator. That is, if I can find the log of 43. So let's see. Log of 43. 1.6335. So that's 1.6335. So then I can write this equation as 10 to the power of 3x plus 2 equals, and since log of 43 is 1.6335, I can write 43 as 10 to the power of 1.6335. And now once again, I can use the same rule that I've been using. I've got a base raised to a power equals that same base raised to a power, which means I can set the powers equal to each other. So 3x plus 2 equals 1.6355. And again, I got to do a little bit of algebra here. Subtract 2 from both sides. That gives me 3x equals 1.6355 minus 2. Negative 0.3665. Negative 0.3665. Divide both sides by 3. And I get x equals negative 0.6355 divided by 3 equals negative 0.2118. And there's that one. Now, problem H, rather, looks a little bit more complicated. I can see I've got a little bit more work that I'm going to have to do before I get it in the form of 10 raised to a power equals 10 raised to a power. But I know how to do that. I want to essentially make this equation look like these equations over here. So I'd like to get all my numbers over here except for 10 raised to a power. So I can subtract 7 from both sides. So my 7's go away here. And I've got 3 times 10 to the power of x plus 4 equals 28 minus 7 is 21. And let's see, if I divide both sides by 3 now, then I've got 10 to the power of x plus 4 on this side, and 21 divided by 3 is 7. And now once again, I see I've got the same situation that I have up here. And in order to write this number as a power of 10, again, I'm going to use the log button on my calculator. Log of 7, let's see, log of 7 is 0.8451. 8451, which means that now I can write 7 as a power of 10. So I've got 10 to the power of x plus 4 equals 10 to the power of 0.8451. And once again, I can set my two exponents equal to each other. So I've got x plus 4 equals 0.8451. Subtract 4 from both sides. And I've got x equals, let's see, 0.8451 minus 4 equals negative 3.155. And I'm done.